In 1972, the heights of rugby players were approximately normally distributed with a mean of 179 centimeters and a standard deviation of 7 centimeters. Find the probability that a randomly selected player in 1972 was A, at least 175 centimeters tall, and B, between 170 and 190 centimeters tall. So this is just kind of a worded normal distribution problem. I'll show you a formal approach. I'll define a random variable and I will illustrate it. You probably would get away with just an answer if you get it right, but it's good to show you how to do things properly, I think. So I'm going to say let x be the random variable so the random variable is the height of a rugby player. You don't need to go too overboard as in writing in 1972, I wouldn't worry about that. Okay, so we've defined the random variable, so we need to say how is it distributed? Well, we've been told it is approximately normal, so x is distributed normally, so we need a mean and a variance. The mean was 179 centimeters. And the standard deviation was 7, so the variance is 7 squared. And I know it seems a bit of a trivial detail, but make sure you write the variance in there and not the standard deviation. Right, so now we need to find the probability. Probability x is at least 175 centimeters. So finding probability x is 175 or greater. Don't forget the greater than or equal to, it really is irrelevant for a continuous variable. It could be x is greater than 175 or x is greater than or equal to. It doesn't make any difference if the variable is continuous. If it is discrete, it absolutely makes a difference. So I'm going to draw a little picture, but as I said earlier, you probably don't have to. It does show working though. So we have a mean of 179 right in the middle. The standard deviation is 7. So 175 is just below the mean, less than 1 standard deviation away. So it's going to be really close, just below. So somewhere like that, maybe. So that's going to ruin my diagram a bit, but I'm just going to write 175 there. Right, and we're interested in it being greater than, so we want this area here. Okay, so that's the little sketch, which does count as working. Then what I'm going to do is go to the calculator, so menu, statistics. We want the distribution and we want the normal distribution. We want the NCD, which is cumulative. It tells you an area. If we go in there, we want to be on variable mode. If it didn't look like this, you need to press this VAR. And then we need to define a lower and an upper bound. Well, the lower bound we can see is 175. And the upper bound, well, it doesn't give an upper bound, so we need to make sure it's obviously outside of this range. So if you think of the heights of a rugby player, I mean, not many people are taller than, say, 2 meters. So if I make them, say, 1,000 centimeter, 10 meter tall rugby player, I've never seen one of those. So I'm going to make this just 1,000. And it's quicker just to pick something outrageous like that than actually to consider, well, what's 4 standard deviations away, what's 5? It's just quicker to just pick something gigantic, or if it was the other way, pick something really, really small or even negative. Okay, so there we go. The standard deviation is 7, and the mean is 179. Just another thing to be careful with. They always seem to be the wrong way around for me. So make sure you don't put your mu and the sigma the wrong way around, because that will radically alter your results. So that's all fine. We have a probability of 0.716. Like this here. 0.716. The answer equals 0.716. So that means that in 1972, 71.6% of rugby players were greater than or equal to 175 centimeters tall. Right, part B. We need to find the probability that they are between 170 and 190. So the probability 170x 190. And it doesn't matter if it's less than, or equal to, but from the wording it sounds like less than or equal to, so we should respect the wording, I guess. So that's what we're trying to find. It's much easier than the first question because we don't have to have this thought process for one of the tails. Both tails are given to us. So I could draw a little picture, but remember, you probably will get away with not doing it unless you're specifically asked to. So here's my little curve. We have the mean of 179. 170 is, with standard deviation is 7, so it's a bit more than one standard deviation away, so it's maybe over there somewhere. 170. 190, well that's just a bit, it's a bit less than 2 standard deviations away. That would be 193, so it's probably over here somewhere. So 2, probably somewhere around here, maybe. It doesn't have to be perfect, but I try and get it as good as I can. But as long as you're obviously to the right of the mean for this and obviously to the left of the mean, it'll be fine. And remember, a good sketch, it does count as working marks. If, say, something went drastically wrong with your calculation after this, you still might pick up a mark, but it might not be worth it for the time it takes. Go to our calculator. The mean and sigma are already in there from the last one. Do check that though, because if I've used the wrong mean and sigma for this, then I might get punished twice. Okay, so the lower 170, upper 190, upper 190, and click through, and that gives us a probability of 0.8426, so we'll call that 0.843. By the way, I'm just rounding these on site. It's probably not a bad idea for you to write the long number down, especially if you're not going to show any working. As in, if you're not going to draw a sketch, then you might have 2-3 marks all riding on this one number being rounded correctly to 3 significant figures. So if you write the long number down, you might take a bit of pressure off that. So that is 0.843 to 3 sig figs. So the answer is 0.843.